There's a couple about similar polygons. The first thing that we are going to know is that similar polygons have the same shape. But different sizes. Okay, so at this point, phone should be put away. So in order for two shapes to be similar, or two polygons to be similar, they want to be the same shape but different sizes. So it's just like it's enlarged or it's shrunk. Okay, and for that to happen, they're gonna have corresponding angles are congruent.
So when you hear corresponding angles, how would you describe that? What do corresponding angles look like? What? Across we'd say opposite. So what's corresponding? Yeah, kind of next to each other.
That's consecutive.
Oh yeah.
Corresponding is what we did in our warm-up where we said like T lines up with whatever, A lines up with B. I can't remember what they lined up with. But they line up with each other. The angles are congruent. And we know that corresponding sides are proportional. 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 Yeah, that's what I did. You just have to do it once and then go back a little bit later and do it again. Otherwise it gets all gross. Alright, the other thing that we know, that we need to know today is a scale factor. And the scale factor is just the increased or decreased. Alright, so at this point you are going to take that handout that I had, and I'm just going to glue in the whole thing. You don't need to cut it. We're just gluing it all in, and I'm going to glue it in on the left side. If you want to glue it on the right side, that's fine, but you need space for us to do our work. So I didn't cut any of it. Just take the whole thing, glue it in. So I should have passed these out. You should have them all at your table. You need to glue that in. Either put it on the left side or the right side. You need somewhere to show your work. Yep, they just pass it around. That's okay. They'll get there. Okay, now that's a good time to do. All right. We're going to use a couple colored pencils. We aren't gluing anything else today, so once you get that glued in, you can put those back in your tub. You don't need to cut it. You just glue the whole thing in. If you cut it, you need to make sure when you glue it in, you're gluing in the different parts.
If they can't quite fit on your page, then go ahead and cut off what you need.
So you can switch that out for the colored pencils. Grab some colored pencils out. I'm going to be using orange, green, and blue. those are good color pencils for today. If you want to use other colors, you can do. Alright, and problem 1, we are going to be given a similarity statement. A similarity statement is really similar to a congruent statement, but instead of using the congruent symbol, we're going to use the similar symbol, which is actually something that we've been doing this whole time. It's a part of the congruent symbol. We just don't use it for the whole thing. Okay? So, for this first one, we know that triangle ABC is similar, so we did just the squiggle. Not the equal sign, because they're not the same, but they are similar, so we do that squiggle. As triangle RST. So in this case, what we're going to do is just identify the things that we know. So we know that the angles are congruent. Corresponding angles are congruent. So if I look at angle A is going to be congruent to what other angle? R, because those are corresponding. First in our statement. So A is congruent to R. B is congruent to what? S. There is no G. It's alright. It's congruent to S. And C is congruent to T. And then I'm just going to write them out. That way we just have them there. If you feel like the drawing is enough and you don't need to write out what's congruent to what, and you're like, oh yeah, I can match that, that's fine. Okay, in order to have the same shape, we have to have the same angles. As soon as we change those angles, the shape is going to completely change. So it's going to look completely different. But in order for it to be similar, it doesn't have to be the same size. So as I look at our sides, if I look at AB, that length, the same size as RS. Is this side exactly the same as that side? Are they the same length? No. But we're going to take each of those sides here and we're going to make them into ratios because a proportion means equal ratios. So if I start from AT and I compare that to the other triangle, what side on this triangle lines up with AB? RS, because it's between the orange and the blue. That's made from the other sides. So now I'm going to name another side from this triangle. Somebody give me one of the other sides, not AB. C. And if I look at my similarity statement, BC is the last two letters. So what other side does it line up with on the other triangle? ST. If you color coded it like mine, it's a little bit easier because I can see blue to green, blue to green. And now this is a triangle, so there's one more that's equal. CA. TR. Good. Yes, you got it. So if we had numbers and we put them in, those would all be equal fractions. 5 minutes. 5 minutes. No. You're posting on Instagram right now? All right, that was question 1. That's all we needed. It's just to know that information. All right, number 2. Our first question we're going to ask ourselves is this similar? So the question is it similar? Are these polygons similar to each other? I just wrote similar question mark because I'm efficient in my notes. But the question is, are they similar to each other? So 2 things we need to check. We need to check to see that the angles line up with each other, that they're congruent. And then we're going to check those sides and see if all those sides are congruent. Okay? So J lines up with Q, so those are congruent. K has those 2 rings. So what's congruent to K over here? R. L has 3 rings. So S. And then if you want to color in M, you can, or you could just leave it blank and know that that M goes with P. So does each angle have another angle it's congruent to? Yes. Okay, so now we have to check the sides, and that's where we're going to line up those sides and those fractions and decide if they are the same. Okay? So it doesn't matter where we start over here, but we need to make sure it aligns with the correct side on the other part. Okay? I'm going to zoom in so you can kind of see what we're doing. All right, so what side do you guys want to start with? Name a side over here. JK. So JK is 20. And I'm going to add to the side over here that goes between the blue and the green. So JK we're going to compare to what? QR. So we're going to compare that to 12. Because that goes between the blue and the green. So our blue and green here is 12. Then it doesn't matter which order we go in. Sometimes it's nice to just go in around that polygon. That way we just keep in mind what we're comparing. But we can pick any other side now. Okay, so KL is 15. And for me, that was between my green and my orange. So everyone take a second. Don't say it yet. On this polygon, which side is going to align with 15? The 9, yeah, the RS. So we're going to compare that to 9. And we need to do this with all 4 sides. Because it might be proportional between 2 sides, but then that third side makes it all sort of wonky. So then we would do 24. And that's between my 3 rings and my 4 rings. Or my orange, my yellow. So what does that compare with PQRS? 14 and 4/10, 14.4. And we need to do our last side, which is 25 and 15. So that's going to be the hardest part about today, is just making sure, just making sure that you're lining up the correct sides with each other. And if that's something that you can remember from those congruent polygons of what lines up with what, that's going to make this a lot easier. If that's something you struggled with, we'll work on that today. All right, so now we're going to use our calculator. And we're going to go through and we can divide these all out to see if they're all the same. If we wanted to, we could simplify the fractions. That's another way to do it. That decimal makes it a little bit hard to simplify, though. Okay, so 20 divided by 12, we get 1.66666666. And we need to double check that these all are going to be the same. So now 15 divided by 9, 666666666. 24 divided by 14.4. 1.6666666666. So far we're on track, but we have to make sure it works for every divided by 15. 1.6666. So are they similar? Yes. Yep, because they're all 1.6, and we were able to match the angles. We had to check both the angles and the sides. So if I write a similarity statement, I'm going to start with polygon, and we can name any angles here in any order we want. So name those in any order. You guys want to go alphabetical? Do you want to just go M, L, K, J, K, L, M, J? What do you guys want? Alphabetical? Okay, so J, K, L, M is similar to, what does J line up with? Q. K lines up with R. S and P. Yep, got a couple people saying that. Good. So even though one side was alphabetical, does that mean the other side is going to be alphabetical? No. All right, for our scale factor, we found out what number was it every single time when we did our ratios. We got 1 point. Comparing the left side to the right, or did we do right to left? Left to right. So what we're actually going to do is, it's kind of goofy, it's backwards. So it's saying if I take these numbers and I multiply each of those numbers by 1.6 repeating, I'm going to get the numbers on the other side. But instead of multiply, what would I do? Divide, yeah. So that's our scale factor. So when it asks for a scale factor, it's just asking what number did you get when you got them all equal to each other. All right, last problem. All right, and problem number 3, DF. Is similar to V, whoop, that's a W. V, W, Y, Z. That would be in our directions. And our goal here is to be able to find X and Y. So when we look at X, what side is X? Oh my goodness, I'm going to freak out on this thing. There we go. What side is X? FD. So FD is going to align with what other side over here? YZ. So does that mean X is just 10? No. When we had those congruent polygons, we could just say, oh, that's 10, so that's 10. But with similar, we have to set up a ratio. So we're going to compare X to 10, because those line up. But I need to say that that's equal to another side that I already have. So what's another side up here that I could use to compare? I could do AF, that's 12, but AF lines up with what? VZ, and that's going to give me another variable. So I don't want to use that 12 because those are going to line up, and that would be too many variables. So we're going to compare 9 to CD is the middle 2, so we're going to compare that to WY, the middle 2, and WY is 6. And then we're going to solve that equation. So to get x all by itself, all we need to do is undo that dividing by 10. We think about that as a fraction, but that fraction line really means to divide. So how would we undo divide? Times. If we do it on one side, we do it on the other side. So in our calculators, exactly what should I type in my calculator? Good. We have to do 9 divided by 6 first. If you're using your iPhone calculator or your Android calculator, you need that equal sign. Then times 10, and we get 15. All right, now for y. What side includes y? What? Not yz. The vz, the 3y minus 1. And do we want that variable on the numerator or in the denominator? Numerator. So we're going to put that on top. So we're going to do 3y minus 1 over. Now that's vz. So vz are the outside here. So what side over here do I want to compare it to? AF. Because those are the outside letters. So AF over here is, and then I need another 2 sides that we want to compare. So we can use that 6 and 9 again, or we can now use 10 and 15 since we have those sides. Do you guys want to use 9 and 6 or 15 and 10? 15 and 10? Okay. If we use 15 and 10, the big thing we have to remember is we started with 3y minus 1. Is that starting with the top polygon or the bottom polygon? The bottom. So do I want to start with the 10 or do I want to start with the 15? We have to start with that 10. Yep. So remember when we have that 3y minus 1, they're together on top. So how are we going to undo that dividing by 12? Multiply by 12 on both sides. So we're going to do 10 divided by 15, hit that equal sign, times 12. And we get 8. At this point, I think a lot of you are really good at solving this equation. 3y minus 1 equals 8. Plus 1. 8 plus 1 is 9.